Okay.
Well, good evening all. Welcome back. It's almost the end of 2016 here, and have another quiet sunset here. A little bit of, looks like a little bit of cirrus, up about 20 or 25,000 feet, and we're just under high pressure. And you can see the map here of Texas showing anticyclonic flow. And what's important is you can see high pressure out in West Texas right there. That's kind of rare. Usually we have high pressure centers pass well to the north of Texas rather than right through the Trans-Pecos region. So when we have that, we tend to get kind of a downslope flow. It tends to be a little bit on the fair side, and temperatures tend to be a little bit warmer than what we usually have with a frontal passage. Okay, let me take a look at chat, and I think our audio is running fine. My levels look real good as opposed to 24 hours ago. And I see we've got Mark and Kevin and Sue and Alexi. Good to see you all join again, and I'm glad to have you on tonight. Looking up north, not much in the way of winter weather. This time of year, we're looking for those big, strong polar outbreaks, very strong Arctic air. We do have that, but you have to go all the way up into the Northwest Territories to find that. We've got a lot of minus 16, minus 11, minus 17. There is some bad data in here, but that's going to indicate probably a little bit of Arctic air starting to work southward. Might have a bit of a Arctic front located right along that line right there. Let me take a sip of water here real quick. Okay, so you can see very cold north of that front and very mild down in Alberta and Saskatchewan south of there. Teens and 20s, that probably means they're dragging out the barbecue grill. Very mild down in California. We see kind of a very weak northerly flow across Utah and Nevada, and a bit of an easterly flow here in Arizona. So that suggests that we've got a bit of a plateau high kind of centered around the Four Corners area and the Great Basin region. And in fact, there's a 1035 millibar plot right there at, I think that's Elko. And let's take a look out on the East Coast. A little bit of a post-frontal situation there with westerly winds coming through Georgia, Florida, and the Carolinas. You can see it's also rather dry. See those 2 points, 17 there around Montgomery, 19 right there at, I don't know my cities out there. I know that's south of Atlanta. I know there's an Army base here. I want to say it's Fort Stewart, but I can't remember the towns. Northeast U.S., same picture, post-frontal air, and we can see westerly winds coming across the Great Lakes right there. A little bit of lake effect snows there at London, and also in northern Michigan. The New England area, though, they're under the influence of a cyclonic system that's just off the coast. See that 991 millibar plot right there around Block Island, or I think that's Martha's Vineyard right there. So, yeah, a little bit of a, this is off the top of the map. Sorry about that. There you go. Now you can see that a little bit better. So winds gusting to 39 right there on Martha's Vineyard. So a little bit of weather off the coast right there, and we'll probably take a look at that on the thickness plot and see exactly what's going on. So that's the picture looking at actual observed data. So let's bring up the actual thickness plots. And again, I always like to go to MAG at NOAA. The maps there are a little bit clearer for analysis. And I'm going to go ahead and click on the NAM. And when we bring that up, we get this picture right here, and you can see that system right off the Massachusetts coast right there. And definitely baroclinic because that ribbon of thickness is right in the center. So that system still has some potential for very strong winds and heavy precipitation, and it's not going to start dying off until that low actually moves north of the band. And at that point, we consider it to be occluding. Surface system looking like this. Falls pretty neatly in that trough offshore. The warm front extending like this out towards Bermuda. And then behind that, there's that push of cold air advection through the eastern U.S. And as we saw out in the Texas Panhandle, a little bit of warm air advection setting in with that westerly downslope flow. So this area here in the central U.S. is under warm air advection. So a little bit of a different pattern, and that's going to, anytime you have warm air advection like that, if you have enough moisture, that's going to start generating some low and mid clouds. Off the northwest coast, there's the thickness band right there, way up north through Washington and Oregon, not down through Nevada and California like we saw. So there's probably a little bit of old stagnant polar air working southward with that northerly wind here, and then we've got kind of like a new reinforcement of cool air just to the north. And then off the coast, looks like another system coming in. And things are probably going to get active out there. I remember what we were looking at on the models yesterday was around the 6th. It looked like the Canadian model was bringing a system onto the California coast. I haven't looked at the models, so it's going to be interesting to see what we have for tonight, to see if that scenario pans out. Which one will win, the Canadian or the GFS? I'm really curious. Excuse me. Hate when that happens. Okay. I think since we're just about to go into the forecast, this is a good time for our building blocks segment. Where's my building blocks video? There it comes. All right, that gave me a chance to recover my throat a little bit. So we're going to talk a little bit about vorticity. And to do that, I'm going to have to bring up a vorticity chart, and I'm going to bring up the Meteostar site because that's one of the better tools here for looking at vorticity. I think the scale that they use is a lot better than a lot of other sites. So what do we have here? Let's see. You can see a lot of red banding through the central part of the country. This is indicating areas of higher vorticity, positive or cyclonic vorticity. And then areas where it's blue or neutral, that's going to be areas of anticyclonic vorticity or negative vorticity. Now you're probably aware that positive or cyclonic values of vorticity are associated with upward motion. But it's actually the advection of that positive vorticity that's important. In other words, this area right here over Virginia and the Kentucky is not getting upward vertical motion within that. It's actually the area out ahead of it, downstream. That's the important area we need to watch out for. Now, you're probably wondering what vorticity is. It does not cause weather. It's important to keep that in mind. Vorticity is a measure of the response of the wind to processes in the atmosphere where winds are out of balance. I've got a chart here that shows you the balance of winds. And you can see that this is a geostrophic wind chart in green. So the green arrows are the geostrophic winds. And that's essentially where the pressure gradient and the Coriolis force are in balance. So it's looking strictly at that and finding out what the ideal wind should be. But the actual wind is in blue. So here, the pressure field or the height field shows that the wind should be blowing to the north in central Missouri on this particular day. This is not current data. But the wind is actually blowing towards the northeast and not the north, and it's actually blowing slower. So this is what we call subgeostrophic wind. It's blowing slower than the gradient should have it going. Another example, here we have winds that are blowing also a little bit slower than the gradient. You can see the winds are showing that they should blow very strongly out of the west-northwest, and they're actually blowing a little bit weaker. So this is an area of, again, subgeostrophic flow. And one thing that you notice is where the winds are out of balance is mostly through here, like in advance of that big trough. And slightly just behind that trough. Out within the ridge, out here, things are pretty well in balance. So actually what's happening is that where the winds are out of balance like this is actually where we're generating a lot of the weather that's happening, a lot of the vertical motion. If winds stayed in geostrophic balance all the time, we would actually have very little vertical motion. So the vorticity chart kind of helps us because it shows us, in a way, some of these areas. Basically, the equations of motion show that we get upward motion wherever cyclonic vorticity advection increases with height. So going back to that one chart, let me go back there. So let me find an example here. So you see this area, a little positive vorticity over Arizona. The advection area is a little bit ahead of that. And what's important is we have to look at where that vorticity increases with height, because that's what actually gives us the upward vertical motion. But that actually gets a little bit complicated with chart analysis. That's too much to keep track of. So forecasters, they generally make the assumption that when you see positive vorticity advection at 500 millibars, there's an assumption that it's probably increasing with height. So, of course, it's dangerous to make assumptions in forecasting, but as a general rule, we can use that, and we can actually look at the thermal advection. Now, you're probably wondering how exactly this positive vorticity translates to upward vertical motion. It's a little bit complicated, but what actually happens is where we have this area of PVA, like right here in California, out ahead of this slug of shortwave energy, the atmosphere is in the process of cooling through a layer. And to accomplish that, there needs to be adiabatic lift. Adiabatic lift will give us cooling, and that will establish balance in the atmosphere to keep it hydrostatic. So that's kind of in a nutshell how we get vertical motion from vorticity. Now, I don't like too many vorticity charts on the internet because they tend to focus on the troughs. For example, let me see if I can show you. I'm going to go to let's see. I'm going to go back to that MAG NOAA site, and I'm going to bring up the NAM, and I'll bring up the vorticity here real quick. So there's vorticity and heights. This is an example of a chart that focuses mostly on the troughs. So you can see it's very well outlined where the positive vorticity is. But but there's not much focus on what's happening in the ridge areas. So I don't really like internet sites that do this too much. Here, there's a little bit of subtlety in the fields. Let me find a good ridge here, and I'll show you what I mean. Yeah, you see that right there in the central U.S.? There's a big ridge through this area. And now, with this particular color scheme, we can see the ridges a little bit better. So right here, this is an area right here of anticyclonic vorticity. It's kind of hard to see that, but that's kind of the absence of coloring right in this area. So that establishes a shortwave ridge. And as you might guess, the area right out ahead of it, that's an area of negative vorticity advection, or anticyclonic vorticity advection. And that's going to be an area of downward vertical motion. And that can be just as important because that'll give you adiabatic warming. That can build your inversions, and that can add to anticyclogenesis at the surface because you're increasing mass in that area right there. So you tend to get high pressure being supported at the surface by these ridges aloft. So that's your 5-minute introduction there to vorticity. I hope that wasn't too confusing. But we'll try to go through some of these little dynamic things, little tidbits like that over the days ahead. And hopefully I'll make experts out of some of you. So let's head into the forecast and get this all set up. Okay, I got the GFS right here. In the background, I'm going to load the Canadian chart. If there's a little bit of a stuttering, just be patient. That's probably just the bandwidth slowing down a little bit. So while that sets up, here we go. Let's go into the forecast. Mark says big snow in the northeast. So yeah, we can see that right off the edge. This is that big northeast coast storm right here. You can see there's a easterly gradient coming in from the Atlantic, and that's going to bring in moisture, warm air from the Gulf Stream waters, and isentropic lift above the cold air down at the surface. And that's a good setup there for heavy snows, and we've definitely got that there over the mountains of New Hampshire, Vermont, and upstate New York. Looks like it's come down pretty good. Probably a fun time to be up there on Mount Washington. So there's the warm air advection coming into the central and eastern U.S. High pressure, as we talked about, over Texas. And let's see what we've got for tomorrow's webcast. Going into Friday here. That high pressure just kind of scoots eastward into Georgia. And now we develop this little Alberta Clipper system coming down. So there it is right there, and a little bit of an occlusion right there. Low pressure located right there. And as you might guess, this is an area of warm air advection. So we're going to see a lot of clouds and upward low-level lift right there. And behind it, cold air advection right there over the Dakotas and Montana. And normally, with that, you're going to get downward vertical motion near the surface. However, as you go closer to the upper level trough, you can get into more of the instability aloft, and that's what's actually happening out here in western Montana. Looks like some convective showers over the higher terrain. And elsewhere, looks like we got a bit of a lee side trough right there over Colorado. Okay, so New Year's Eve, what do we have going on? I don't know how many of you guys are going to be out partying on Saturday. I have no idea what I'm going to be doing, but we'll see what happens. That little Alberta Clipper looks like it kind of moves eastward through the Great Lakes right there. So we saw it earlier over the Dakotas, shifting out that way. And we get a kind of a cool push into the central U.S. right there. So it looks like maybe a little bit of that cool air comes southward through Oklahoma and Texas. And on the first day of New Year's, Looks like that little high pressure push kind of washes out. A little bit of a backdoor cold front maybe into Oklahoma and Texas. I would bet there's probably a little remnant of a front through here. But up to the north, new frontal system coming together in Montana and Wyoming. So we're going to see that push southward over the 2nd on Monday. Here it comes southward right there. Big 1040 high in the wake of that. And things get active in the southeast with this strong warm air advection and maybe some lift over that old frontal boundary. And then for the 3rd, more high pressure working south, and this is where we get a pattern change in Texas and Oklahoma. And that rapidly shifts southward on Wednesday. So now it's starting to look pretty cold. And one thing that you've probably noticed, a chunk of that polar air has pushed over the Rockies, and it's now finding itself in the Great Basin area. So this is probably a very deep polar air mass shifting south, covering this entire area. And now we have Southern California becoming active. Let me switch over here. Looks like the GFS is kind of coming into line with the Canadian model. Canadian model has actually been doing pretty well this winter. So the GFS moves this system towards Texas and New Mexico. Look at that. Pretty good little winter storm right there. New Mexico right here, they've got a strong easterly upslope component over Tucumcari and Roswell, and also an upper level system moving through. Well, it's actually kind of surface based, but it's actually sliding over the cold dome, and so that's helping to increase the isentropic lift just above that cold dome. So underneath it, there's that upslope, so upward motion at all levels. And that's a good recipe for heavy snow. Looks like I clicked the model right there, or the SKU-T. Bring that back. And things look pretty exciting here for Texas and Oklahoma on the 7th and 8th. Moves rapidly westward. So yeah, this is going to be rooted mostly in the upper levels. Just because of the speed, it moved eastward. See that right there? There's the 6th at 18Z, and then the 7th at 18Z, all the way out to Georgia there. So that's going to be mostly an upper level system. And look at that damming there in Virginia and the Carolinas. See, the cold front is going to be something like that. So we got all this very cold air kind of blocked by the Appalachians. And we're getting lift on top of that, so that's a good recipe there for freezing rain, sleet, and snow there. Okay, 25 minutes in. We'll just go ahead and finish this real quick. High pressure coming southward through the Great Plains. And looks like the polar air masses up in Canada are still pretty active. They're being blocked a little bit by Pacific systems coming inland. And we get to the end of the period, big Pacific system out in Oregon and California on the 14th. And let's take a quick look at that Canadian model. See if we have any differences there. We'll run this up to the 5th. Canada's model brings the system a little bit further north into Central California and Nevada. So there it is right there. So not so much of a bad pattern for New Mexico and West Texas. So this is mainly hitting Colorado, Nebraska, and South Dakota. Once again, it will be interesting to see which model gets it right. GFS going for snowstorm in this area, Canadian model going for snowstorm in this area here. This is where it would be good if we had the European model to kind of see which one is more in agreement. However, at the very end of the period, well, yeah, it's still keeping the Pacific active here. So should be a fun pattern here over the next few weeks. Well, I'm about all talked out here. I hope you enjoyed the webcast and the little refresher on vorticity. Mark says 996.9 millibars in southern New Hampshire. Pretty good storm there. And Weather Service calling for thunderstorms with that system. Wow. Okay. I hope you have a good evening, and I'll see you tomorrow.